is your Thursday going? 14th of December. So we're now more than halfway through. And looks like the elves have sent us a couple of pages of their problems again. So let's see. What we have here to solve today. 2 pages. 2 pages. Okay. Okay, so what is going on today? Day 14. Parabolic reflector dish. You reach the place where all of the mirrors were pointing. A massive parabolic reflector dish attached to the side of another large mountain. The dish is made up of many small mirrors, but while the mirrors themselves are roughly in the shape of a parabolic reflector dish, each individual mirror seems to be pointing in slightly the wrong direction. If the dish is meant to focus light, all it's doing right now is sending it in a vague direction. Okay? This system must be what provides the energy for the lava. If you focus the reflector dish, maybe you can go where it's pointing and use the light to fix the lava production. I depict this, I'm feeling this Indiana Jones moment. That's a classic, like the one where they fall in the like the pyramid tomb, and there's those snakes, and then Indy moves the reflector dish. This seems like that kind of moment. Upon closer inspection, the individual mirrors each appear to be connected via an elaborate system of ropes and pulleys to a large metal platform below the dish. The platform is covered in large rocks of various shapes. Depending on their position, the weight of the rocks deforms the platform, and the shape of the platform controls which ropes move and ultimately the focus of the dish. In short, if you move the rocks, you can focus the dish. The platform even has a control panel on the side that lets you tilt it in one of the 4 directions. One of the 4 directions, okay? The rounded rocks O will roll when the platform is tilted, while the cube-shaped rocks hash will stay in place. You know the positions of all of the empty spaces, period, and rocks, your puzzle input. For example, okay, so there's a map with periods, hashes, and O's. Start by tilting the lever so all of the rocks will slide north as far as they will go. Okay, so they all drop, yeah? You notice that the support beams along the north side of the platforms are damaged. To ensure the platform doesn't collapse, you should calculate the total load on the north support beams. The north support beams. The amount of load caused by a single rounded rock is equal to the number of rows from the rock to the south edge of the platform, including the row the rock is on. Cube-shaped rocks don't contribute to load. So the amount of load caused by each rock in each row is as follows. Okay, so here are the rows. So this one is a 10, and that's a 1. The total load is the sum of the load caused by all of the rounded rocks. In this example, the total load is 136. Yeah. Tilt the platform so that the rounded rocks all roll north. Afterward, what is the total load on the north support beams. Ooh, today is a simulation day. Simulation day. Yeah, well, I guess we're gonna simulate. I wonder how big this landscape is gonna. Okay, so the first thing, save the inputs. So let's go here and find the inputs. So this is the input, right? Your puzzle, yeah. Let's save this. 9. Example 14. Okay. And then the actual puzzle input. However much of data that might be. Okay, can I fit the input in the editor? Oh, yes, I can. Okay. So how big is this? 25, 50, 75, 100. Let's start like 100. Yeah, 100 and a couple more. How wide is the input? That's 40 columns. um, 40 plus 10 plus 20, about 50 columns. So it's like 50 by, roughly 50 by, wait, now I already forget. 25, 50 by 100. 100. Yeah, 50 by 100. So about 5 kilobytes. Yeah, that fits really easily. About 5 kilobytes. Although I'm thinking that I wouldn't even need to store this whole map in memory. If all I was doing is rolling up, I'm probably gonna be rolling to the left and right and down because it said 4 directions. So yeah, I better store the whole map in one go. Otherwise I will be in trouble. This feels like Boulder Dash. This is a Boulder Dash problem. Yeah, alright. Alright, let's get going. So 50 by 100. Include libc. Int main. File f equals f open. 23.example 14 txt from device 9. Map. Let's do 64 by 128. So that's, is that 8 kilobytes? That's 6 bits and that's 7 bits, so 13 bits total. Yeah, 8 kilobytes. Okay, so fread. How did this go? Into map, size of map 1 from F. Okay. And then U8 width equals stir map new line minus F close here. Let's give this a go. So yep. Width and then well, this is going to be rounding down, so this is not necessarily correct. Although I think it should. But let's see what this says. 95 by 1. Okay. Did I mess up my line ending? Oh, I didn't. Yeah, now I remember. I didn't fix my Advent of Code client. I still have that line ending back. Okay, so the first one is 10 by 11. 1, 2, 3, 4, 5, 6, 10. Yeah, 10 by 11. So actually width is +1 of this, because I do need to include the new line. 11 by 10, yeah. And then if I run on the actual input, let me save this. If I run on the actual input, now I need to do the R. So this is supposed to be roughly 50 by 100. What? 101 by... What on earth? 101 by 81. Maybe I calculated wrong. Maybe I estimated wrong. Okay, but I do want to make this work on both, so I'm gonna do this. is not, or greater than 32. That's weird. So this is the code conflict I had the other day. Actually, it should work with just this space as well, right? Oh, no, let me try on the example. Oh darn, I crashed. That was a proxy bug. Need to figure that out at some point. Okay, so that's what I would like to do, but now I need to work around with this. Oh, which one did? Oh, now I put it on the real input. Okay, whatever. Well, I should get the same 100 by 80. No. 10 by 8, 21. What? What the heck? Oh, map. G. Eleven by 10. Yeah. Okay, now it's gonna work. Cool. All right. So now I have the map. Now I need to move all the rocks to the top. So for char star M. Oh, I wish I would have a sentinels. No, but I can add sentinels, but I do need to then move the map in 4 directions. So actually, yeah. Let's do a boring 2D scan. Technically this would need to round up though, but I don't need to care about that because the input is well formed. And then if map, let me do define at x, y. Y times width plus x. Yeah, this will get promoted to an unsigned integer, so I shouldn't be overflowing or overflowing an UA. So if map at xy equals a boulder, I am seeing like 4-level nested thing, so let me do a function. Void roll u8 x u8 y. I'll probably expand this to include a direction, but for now it's just gonna be rolling up. So I need the u8 weight height. I need them to go here. While y is greater than 0 and map y minus 1. Oh, map at x y minus 1. I'm feeling it including the map here, but this was last time I think when I did this, I had this horrible bug that took me so long to figure out. So now I have to be careful. Now I have to be careful that I don't repeat that bug. So that was the pipe day. I had this horrible bug, but let's let's go like this. Equals period. Minus y. Actually, at xy equals. So first we need to clear the rock, and then we move upwards, and then we put the boulder back. Yeah, that feels good. Roll. Let's save. And then we score. Or what's load? Total load. I can score while I roll, right? Oh, but I don't know the new code. Oh, whatever. I could return it from there, but yeah. Load. Oh. No, I really do wanna. I could return the new y because x is gonna be the same. Yeah, let me do that. Oh. U8 return y. Load plus equals what is this? Height minus roll. Yeah, that should work. So if I'm rolling all the way to the first coordinate, this should be just height. And that should be 10. Oh, what did I do? Okay, printf total load Total load supposed to be 136. Yes. Yes, okay, it works. It works. Okay. What does the input say? Seven 72702. That's a nice number. So let's go Command A. Seven two seven oh two. Oh, not the right answer. Too low. Wow. Wow. Okay. Why would... So if we have a boulder here, minus row. Wow, I'm stumped. I'm stumped. Did I do a mistake? Let's print here. Width, height. Actually, let me just do. Just to double check, I didn't do any mistake here. Hundred and one by 81. Okay, now I think I do want to print this map. So for char s equals map. S. I equals 0. I equals 0. So I'll turn the oh, what do I have here? I'll turn the new lines into delimiters so that I can easily print s. S equals s plus equals I plus 1. Oh, no, not map. S and is not base. Actually, what? Let me do it like this. Si. If not Si. Or if I equals 0, break. What happens with this? I'm thinking that maybe I'm calculating. Oh, what did I do? Oh, crap. I'm thinking that maybe I'm calculating the height wrong for my actual input. And that's what causing the value to be wrong. Okay, yeah, not that easy to follow, but let's see what happens here. Oh, I have some crap at the end. Did I screw this up? Yes, Si equals 0 already. Maybe that's what I want to do. Yeah. Yeah, that's what I want to do. Oh, I probably should have printed line numbers. Yeah. I need to do that. Okay. So this looks very much like it's 100 units wide. So that's right. But maybe my height. Yeah, I did get some garbage at the end. What was that about? Okay, let's print the line numbers. So int line number equals 0, and here I put in the line number plus plus. Let me add another one. Zero, 1, 2, 3. Okay, so I should have 80 of these lines. Or 81. Do I have a off by 1? Line 80. And I had 0 base indexes. So this is 81st line. What is that? $81. What on earth? At 0, I have the file name. Yikes. So I have like stray 2, 4, 6, 8, 10, 11, stray 11 characters on an extra 82nd line. How bizarre. As if that is part of the file, because 82nd line, 82, so 83rd line is then an empty string. So that's the last, after the last new line. What the heck? Okay. Change of plans. No F read. Let's give this a second go with F gets. I'm going to do char S 128 while F gets S size of S from file. Mem copy map S string length of S. Actually char star D equals map. Char star D equals map. D plus equals do the line numbering. Isn't D, isn't S, L plus plus and then S. F close 0. Get done. Yeah. Well, this turned out to be an interesting debug experience. Zero. So yeah, the first line, second. Yeah. Okay. Let's just let these roll. getting pretty close. So that's 81st line. That's a full line, good. Good stuff. And that's 82nd line. So now I'm getting more. That's 82nd line. 83rd, what? Ooh, so something is so fishy with this one. I got corrupted data read with this one. Wow, okay. But then I think I should be just okay to use this for the time being. That's very interesting. Okay, so I do have a debug experience to go through with this one. And then I do... So what does this thing tell me? I'm going to skip all of this stuff. I'm not going to need it. Yeah. All this can go away. And now I'm simulating again. Let's actually run the example. Total load 20. Should be 136. Oh my. Oh, that's because... Oh, no. Because I had to have... I had a global... Yeah, these are globals. I don't do this. Total load is still 20. Which is why. Oh, no, not plus. Oh, where's my D? Jeez. D plus equals with. I didn't advance this pointer at all. Okay, 136. Okay, now it's good. So. Now let's save. F-read betrayed me. I looked at this the other day and I couldn't figure out an issue, and at least like an obvious issue, by reading it. But maybe I used it wrong or something. So I have 83 lines. Ooh, and now I get the different number, okay. 76154. Well, that's at least higher than before. 76154. Answer 76154. Still too low. Seven six one five four. Still too low. No. Well, I guess this should be like this, but that shouldn't matter. Okay, let me debug my actual algorithm. Okay. Oh, no, it's, yeah, first gonna do all of that. What seemed like a simple thing turned out to be a massive debug day. Oh no, I added a new line after my character. No. No, 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 no. Why did I do that? Gee. Let me run it. Well, the example is right. I mean, there's nothing there. And the height, so height is 83 like it should be. Okay, here we go again. Okay, 7615, yeah. Yeah, hard to debug from here, but I get lots of rocks at first. and then fewer and fewer. Yeah. No, there's a lot of rocks still. Well, let me debug the whatever fits on screen at least. Okay, so now they should be in that vertical order. Yeah, that looks like a well simulated roll towards the north. Everything is nicely moved up vertically. Just as it should be. Very peculiar. It's still possible that I'm getting the height wrong. Somehow parsing the input wrong. No. No, I'm not getting that. Yeah. Hmm. Okay, what I'm gonna do is, given that I am able to load the input, let me double check that. Your puzzle input. Oh, actually. So this is now 40 columns. I can see 40 columns. Now I've scrolled 40 columns to the left, so now I can see 80 columns. So that's exactly 100 columns, yep. And then if I go down, so this is 25th row. So now I scrolled up 25, so this is the 50th row. This is the 75th row. This is the 100th row. Wait, the 100th? Oh, wait. No, yeah, 100th row. So this should be 100 by 100, not 100. So somehow I have saved a partial file that doesn't have the full input, because this is 100 lines and I got 80 lines. Okay, so that is the issue. So I got cut off by 20 lines. Wow, okay. Wow. Let's try in14.txt. How peculiar. But yeah, that is clearly the issue. It's 100 by 100. And And originally it's just saved 80 lines of that input in. So that's why I was getting the wrong answer. And yeah, that would come out as a smaller. So I should be getting like 10,000 bytes written because it's 100 by 100. Yeah, 10,100 bytes. Wait, what? 10,100. Oh, because of the new lines. Okay, so 10,000 map characters and then 100 new lines. Okay. Oh, okay. How does that kind of bug happen? I might have been looking for that one for a long time. So I have to really figure out what's going on there. But anyway, so now I think I know what the issue is. So 2020D 14 negative. And let's do this on input 14. And I think here, yeah, I don't do partial, like I only now accept if I get a full line. So now if I get like empty new line or something, I don't accumulate that. And let's get rid of this. Okay, so what's gonna happen with this one? Okay, so now I should get 100 lines in the input. $82 again. 76154. Wait, what? Oh, actually, this is. Yikes! This was actually wrong, but. Actually, given this isn't the global data section, so this would have overflowed on the dynamic heap area. Why did I even do 6? Well, because I first calculated 50 by 100. Yeah, I counted wrong. Okay, so that was but I think. Oh wait. That could go. Oh my god. Oh my god. Is that the issue? Is that the issue? That I calculated. Actually, that might be the. That might be the issue. No. And that's why the file name was also in the map. Yeah. No. Probably there was nothing wrong with the F3 in the first place. Oh my god. 108614. Okay. Yeah. Yeah, that's why we have modern save vectors. Okay. Do I get lucky now? One sec. 108614. Yeah, that's right. Okay, so I calculated the width of the map incorrectly. I visually eyeball it to be 50 in the advent of code, and then I put in that, or was it 60 rows? But I miscalculated it. It was actually 100 rows, and then everything got corrupted. And probably the F read was just fine, but it was just corrupting everything there. And yeah, then it all just went down from there. Okay, part 2. Jeez. So that took me like 40 minutes to go debug. Wow. What a fight. Okay, so let's take in the second part. Oh, and it doesn't want to print. It's giving me the error again. Why don't you want to print? Reset. Goes to an error state some reason. Where is the power button here? Okay. Okay, now it's printing. Cool, alright. That's that. Okay, 2 pages again. Let's see. The parabolic reflector dish deforms, but not in a way that focuses the beam. To do that, you'll need to move the rocks to the edges of the platform. Fortunately, a button on the side of the control panel labeled Spin Cycle attempts to do just that. Each cycle tilts the platform 4 times so that the rounded rocks roll north and west and south and east. After each tilt, the rounded rocks roll as far as they can before the platform tilts in the next direction. After 1 cycle, the platform will have finished rolling the rounded rocks in those 4 directions in that order. So, north, west, south, east. Here's what happens in the example above after each of the first few cycles. So after 1 cycle, after 2 cycles, after 3 cycles. This process should work if you leave it running long enough, but you are still worried about the north support beam. So to make sure they'll survive for a while, You need to calculate the total load on the north support beams after... Oh, okay. After 1 billion cycles. In the above example, after 1 billion cycles, the total load of the north support beam is 64. Okay, so the thing is that there's a fixed point. But shouldn't the fixed point occur in just after one cycle? No, not necessarily, no. Do I just simulate until I find that I am at the fixed point? But the fixed point is not necessarily just indicated by the score. So I cannot calculate the score after each cycle. Or I mean, I could try it as just an unsafe thing. And it costs quite a bit to copy the map. Maybe I would have a I was thinking maybe I would have a vector that would tally the count. But still, that might still not be accurate, so I would really have to copy the map. Until I am at a fixed point. Okay, so I'll just have to copy the map. Yeah. Or actually, maybe I'll cheap out and I'll first try a way where I do the 4 rolls a couple of times. Then when the score stabilizes, I'll just submit that score. Yeah, I'm gonna go fishing. I'm gonna go fishing with that. Okay. That's what I'm gonna do. Spinning rocks, not quite as Boulder Dash. So let's save this immediately to 14B CPU. Actually, I think this didn't happen. Yeah, I don't want to change this right now because I already have this in there. Just keep this here. Okay, but yeah, I'll look into this. Yeah, I think this I probably didn't have any bug here. It was just my manuals. How much memory is this? 7 plus 7, 14. So that's 16 kilobytes, so that should work. And then I can do this. Yeah, so this speeds up things considerably. Let me run this to double check that I am still computing the right result. For part 1, that is. And I am not. Jeez. Why am I not? What? Well, let's put this back. Okay, now work. Wait, what? Seven bits should definitely be enough. You don't have a mistake with parentheses. Like this. Seven bits. 128. Definitely should be enough. Definitely should be enough. But no. What? Oh. Oh, I'm so stupid. I'm so stupid. Okay, today I'm so slow. D plus equals 28. Because I'm making the width 20. It looks like I am not waking up today. So this would be the 108,000. Yeah, 108,640. Okay. So now I can avoid multiplications inside this simulation loop. That makes several seconds worth of difference for the C64. So maybe I'll copy these. Roll up. Does that make sense? Yeah, let's pack this up. Roll left. While x greater than 0, x minus 1. minus minus x at x, y. It's gonna be bolder. U8 roll down while y is more than height and x plus 1 plus y. And then roll right. X more than width. Oh, but here. Ooh. Here I need to be careful because my map includes the noon line. Well, actually, now I can do the width to be. Because I've my stride is now fixed to 128, so now I can actually compute the correct width. Yeah. Okay, so roll right, smaller than width. Oh, bug, no, bug. Plus x. Width minus 1. Minus 1. Yeah. Okay, so let's see. So what I then do is oh, but I need to take okay forever. Load equals 0 initially. Roll up. Down, left. No. Roll up. Left. Down. Load plus equals. So rolling to the right doesn't change the load because it's only the vertical aspect. So I'm going to calculate the load here. Oh, actually now all of this looping is starting to make me think I should be tracking the XY coordinates of these boulders instead of operating on this map. But I'm hoping that the fixed point is going to be in just like a couple of steps. Previous load equals 0. Actually, total load. Yeah, let me do this. Roll down, roll right. I don't need to return this anymore. Right. Yeah. Okay. Oh yeah. Okay, so now I'm curious to see what happens to the log. Let's see. Let's see for the example input. Oh. 2023, the example 14. Oh, and I should clear the load. Load equals 0. So total load is 64. Well, it doesn't seem like it. But yeah, the fixed point does come pretty quickly, so... $64. Okay, now everything looks good there. Okay, so I guess I'm visually debugging. Let's put this back. Okay. That works for debugging. Okay, so everything goes to the up. That looks good. Everything goes to the left. Yep. Everything goes to the down. Wait, what? Wait, what happened? Okay, let's put in... Let's put in a delimiter here. Okay. Everything went to the up, they went to the left, they went to the down. But why do I... It's printing once every... What the heck? What the heck is happening? Okay. F. Up. Oh, wait. Left. Down. Oh no, no. Oh, I ran out of memory. Okay, let's save and actually let me reload this page. Okay. Okay, so now I'm getting the right result, or the 20, 116. I mean, not the right result, but the actual for... Oh, okay, so I should be getting 64. So after one cycle, I should have went up, went left, yep, went down, yep, went right. After one cycle, wait, my map looks completely different. Okay, I'm corrupting something really bad again here. Aren't I? Okay, so... what am I screwing up here? So my stride is now fixed 128. That is... Initial. What was the initial? Yes. When I go up. When I go up once. Yes. Okay, so that one is also correct. When I go left once. That looks also good. When I go down. Oh, this is not right at all. I didn't go down Oh, now I don't. No. Ah, gotcha. Yeah. Nice. Okay, let's go down. Page -2. Well, I mean, like, yeah, you. Oh no, I do have to do h-1 so that I calculate the. Nice, gotcha. Okay, and then when I do left, I do need to go in this direction, and then to the right, I need to go in width -1 x greater than 0 -x. Yeah, that was a nice one. Okay. Okay, so now I might be converging to the right result, hopefully, maybe. Let's see what happens. Up, left, down. Yeah, now everything moves. Right. Is that the thing after one cycle? Yes, it is. 93, 111, 111, 115, 116, 115, 117. Oh. But now I'm getting really interesting numbers that really do fluctuate. Oh, but maybe there is no fixed point, but there's a fixed cycle. But in any case... Okay, let's get rid of this printing. So that I can see what is going on. Could that be the case? Okay, that's the initial. Yeah, so there's no fixed point, but there's a fixed cycle. Okay. Well, that's not too bad to handle either. I mean, except that I would have to somehow yeah, I feel so. So I would have to I would have to memcopy multiple, like give multiple copies of this map. Or I could do like an unsafe hash, but yeah, and then when I see the loop, then I fast track my iteration count. This is similar to that Tetris puzzle from last year, but yeah, the fact remains. Okay, so now I'm getting. Now I am getting results, but the issue is that I'm computing the right or the wrong results. So why am I getting the wrong results? Initial. Wait, what? Okay. After one cycle. Yeah, this is right. After two cycles. Yes. After three cycles. Yep. Total load 111. Let's calculate one. So that's 4 plus 2 times 2 plus 3 times 3 plus 2 times 4 plus plus 2 times 5 plus 3 times 6 plus 1 times 7 plus 1 times 9, which is 4 plus 8 plus 9 plus 8 plus 10. Let me actually do this here. Plus 10 plus 8, 10, 18, 7, and 9, which is 12, 17, 28, 16, which is 29 plus 38, 44, which is 73. So load should be 73 and I'm getting 111. Okay, so this is definitely wrong. And so it's wrong if my load equals roll down. If my height is wrong, is my height wrong? height equals load and height. Oh. Oh, that was the load height. Okay. Let's see what happens with this. 10. Which is correct. Roll down. Oh, height minus, geez. Okay, so now I can see I have this 64. Was that the supposed? 64 is supposed to be the, okay, so now and this cycles. Okay. Now let's get rid of this. So I can fish for the cycle in an unsafe way. But do I have the memory to? Actually, let me use this one because I know that worked. Do I have the memory to do this the right way? Oh, but I'm still printing the initial map, aren't I? I think so. Yeah, okay. Oh, this is being super slow. Super slow. Ouch. Okay. Yeah, I should keep track of the coordinates. Yeah. So if I if I kept track of the coordinates, simulation would be faster, but but I still have the challenge that so right now my map takes 16 kilobytes in memory. And I would have to track the cycle length number of copies of that map. But I don't know what the cycle length is gonna be, so actually I have to keep all of these copies. I cannot do that. So I would have to do like an unsafe hash of the contents of the map. But can I just go by these load values? Yeah, actually, maybe I would assume. Yeah, maybe I would go by the load values. And let's say let's say I assume that the cycle that the cycle would be, I mean that there would be a cycle and it would be at least like three elements long, maybe. And then if so, I could keep a history of the 3 most recently seen load values. Oh, but then they would also would have to have the whole history of these loads. Maybe I do it visually. No, well. Yeah, let's see if I get to some values where I could calculate this by hand. But yeah, if I was on a PC, I could just, you know, roll this like until I detect a real cycle. I could store all of these. Like I guess I could store all of these here as well, right? And then keep looking for a cycle. But so far it doesn't cycle. Or maybe this is gonna take several hundred iterations before this cycles, so otherwise I would need to shift to that. Oh, but the challenge is if I start tracking, if I keep an array of the boulder positions, then I get this issue that I need to track which order to update. But I could maybe make the boulders hop over each other. Then the order wouldn't matter. That might be a thing. Keeps coming down. Oh, now it actually increased. Was it increased before? Not quite sure. Yeah, now it increased. Okay, now again it got smaller, yeah. Well, what I'm gonna do is I'm gonna leave this running here for some while, and I'll come back to this in a little bit. Or maybe in a longer bit, and see what these numbers look like, and if I can visually find the cycle, then I think I'll calculate the cycle based on that. Otherwise I am going to yeah, otherwise I'm going to optimize this a little bit. Probably off stream. Oh wait, now there's a repeating 97322. Oh, but that didn't follow. No. Yeah. Okay, it's still going. Yeah, all right. I'll leave this here for a while, and I'll be back maybe in half an hour or so to see what's going on with this calculation. All right. So take care, internet. See you in maybe half an hour.
Hello, internet. Okay, I'm back, and I admit I couldn't resist. I solved the the problem on the PC, and yeah, it turns out this this computation is already now going in the loop. So this is now already in the cycle, and that I calculated on PC. The cycle length is 70. So cycle length is 78 iterations. So that's when it cycles, and the cycle starts after having finished the 97th iteration. So this one is already in the cycle, and basically to make this work, what I would do here is, wait, where do I increase the iteration here? So plus iteration. So if I put in here if iteration equals, so after 97th iteration, that's the cycle. I can do calculate. So I have U64 iterations left equals 1 billion minus minus the current iteration that we finished. And then I can do well, for example, I can divide by the cycle length, which in this case is 78. So if I do something like this, this tells me how many full cycles I have now completed. So then I do iter plus equals iters left. And now iter was a U16, so I'll change this to U64 and do while iter is not 1 ULL. And here I think the print is iteration equals LLU. Yeah. So basically after now the 97th thing, it should find itself in the right result. Now computing this will take, I think, longer than what I want to wait here. But yeah, I'll look into some optimization. So this is clearly, the second part is now beyond the C64's capabilities. So I'll have to figure for a way how I could make it past this one. But yeah, on the PC, this one is quite of course like immediate to calculate, but on the C64, yeah, this takes quite a while. So yeah, let me show you the advent of course. So on the PC, 40. Oh, it's not showing any stars. That's weird. Okay, so 14. So I submitted the answer on the PC for the second part. Got 96447, and yeah. So cycle length of 78. It requires a little bit of memory to figure that, or to like to keep track of. Or let's say like 96 plus 78, so that's 164. So if I do this naively, which is like peanuts for a PC, I would keep copies of each board state. So I would have 10,000. 10 kilobytes for each board state, and then keep a copy of each in a hash map, and then you would be looking at each iteration. Did I now reach a state I've seen before? Because then it's gonna loop. So this would be 97 plus 78 of total. So that would be the 175. 175 times 10 kilobytes. So this is 1.75 megabytes of memory, which is too much for the C64 to handle. So I cannot keep full board copies in memory. But I wonder if I could do this kind of unsafe hash thing, where I hash the board state, let's say maybe to a U64 or something like that, or some other value that would have content. The score values is not enough. It's not good enough of a hash, because those do repeat even before the cycle. But I think this approach would be able to work. So I have to see if I get a chance to implement this, and then see if this manages to work on the C64. But yeah, so this problem was quite similar to the puzzle that we had in last year with the infinite Tetris playing board, where you had to store the landscape in a hash. Here it's like the board state, and then you were looking like when the landscape cycled and then repeated stuff. Cool. Okay. Okay. So basically that's that for today. Only 1 star for the C64. But maybe I can figure it out and help it out to do the computation. In any case, that's everything for today. So take care, and I'll see you tomorrow in the next puzzle. Bye.